Alright, so this is the last screencast for the chemical reactions unit, objective number 11. We're going to talk about Le Chatelier's principle and how it relates to chemical reactions as well as chemical equilibrium. There's 2 video clips that we are going to watch in class, and the majority of this, just like the last objective, will be learned through lab. So Le Chatelier's principle, we're going to do a lab activity and possibly 2 PhET simulations. But if the basics is, if a stress is applied to a system in equilibrium, the system will respond in a way to relieve that stress and restore equilibrium. So if you take a system that's already happy and hunky-dory and the forward and reverse reactions are in equilibrium with each other, and you apply a stress, meaning you put more reactant in, or you start stirring it, or you change the temperature, if you mess up the equilibrium, then it's going to try to fix whatever you did to it, which seems kind of common sense that it would try to reverse what you did. So the system tries to reverse the stress. So the effect of changing concentration. There are some things that'll stress an equilibrium. Changing concentration is one of them. If I were to suddenly increase the reactant concentrations, if I were to add more reactant to it, there's now more to react. So that's going to increase the speed of the forward reaction because there's now more collisions between those reactants and the forward reaction. So now it's going to make more product. So I would end up shifting my equilibrium. So when the concentration of the reactants, or just one of the reactants, is increased, the equilibrium is going to shift right. It's going to shift toward the products to try to get rid of that reaction, or those reactants. If I were to increase the concentration of the products, or one of the products, if I were to add more to that system, that closed system, the equilibrium is then going to shift left. It's going to shift back towards the reactants. So you have to think of it in terms of the opposite. If I do something, what is the effect going to be? And it's the opposite of whatever I did. If I added reactants, it's going to favor products. If I added products, it's going to favor reactants. Pressure is something else that you can use to change reaction rates, but it will affect them when one of the reactants is a gas. So if something is not a gas, pressure is not going to have much effect. Remember, one of the properties of a gas is you can condense it down. So by increasing the temperature, that has the same effect as increasing the concentration. I lower the volume of the gas, that'll increase the pressure, or if I just add more gas. So I could change the volume, decrease the volume, or just add more gas to the system. If the system is closed, meaning nothing can escape, nothing can get out, the equilibrium is going to shift to the side with the least amount of moles, which is kind of interesting. So if we look at these examples, the coefficients in front, you're going to learn in the next unit, tell you how many moles of that substance you have. So if I, like this is read as 1 mole of nitrogen plus 3 moles of hydrogen will give me 3 moles of ammonia. So if I increase the pressure of the reactants, so on this side, if I lower the volume or I just add more reactants to it, if I increase the pressure on this side, I'm going to shift the equilibrium to the product side. Because there's 4 moles here, 1 plus 3 is 4, and there's only 3 moles here. So it's going to favor the side that has fewer moles. In this reaction, I have 1 mole of nitrogen plus 1 mole of oxygen gives me 2 moles of nitrogen monoxide. So if I were to increase the pressure on this side, I have 2 moles on this side and I have 2 moles on this side. So by increasing the pressure, I would increase the reaction rates, but the forward and the reverse reaction are both going to increase. So my equilibrium is not going to change because I have the same number of moles on both sides. So pressure can change reaction rates when things are gases, but you have to pay attention to the number of moles. That tells you where it shifts the reaction to. The effect of temperature on equilibrium, we've already kind of discussed. As I increase the temperature, I increase the kinetic energy. So I just mean there's more collisions, so that the reaction occurs faster. The reaction that absorbs heat, the one that takes heat in, because if I give it heat, I'm giving that part of the reaction more of what it needs. That's going to speed up and shift the equilibrium to the opposite side. So in an endothermic reaction, my forward reaction increases because I'm now giving it the heat that it needs to react. So it's going to favor the products. If it's an exothermic reaction, it's already producing heat. I'm giving it more heat. So now it's going to try to absorb some of that. And so the reverse reaction increases and it's going to favor the products or the reactants. So you just have to think what's going to be the opposite. It's going to do the opposite of whatever it is to try to reverse it. And like I said, we're going to do this in a lab. So the summary for objective number 11 is a 20-word summary.